Quantum modules in full color. What you see here is a geometric model of a quantum module system, similar to what Fuller defined in Synergetics 2. I have color-coded the faces, which guide the user to create various shapes that can fill space without voids. Larger structures can be quickly built from smaller submodules, or large shapes can be fractured into smaller pieces and rearranged into different shapes. So have some fun and enjoy learning the basic geometry behind a quantum module system. All of the shapes you've just seen in this video have been constructed from these four shapes. There's two tetra modules, a left and a right, and they connect by common color. And there are two octa modules, a left and a right, and they also connect through common color. And the tetra modules connect to the octa modules between their black and white sides. And this makes your simple submodule of 4 the basis for all other submodules to make much larger shapes. This is similar to what Fuller defines as quantum modules in Synergetics 2. These tetra modules are identical to what he calls mod A. However, the octa module is actually a union of what Fuller calls mod A and mod B. So there's a slight difference there, but otherwise it's quite similar. It's a space-filling model, and it's designed to help you build shapes to fill space. However, there is one caveat, is that you should not connect two blacks or two whites together. That typically leads to something that's non-space filling. It's no big deal. In fact, it leads to some interesting shapes that I'll be showing you in a following video, but for the time being, I'll be avoiding connecting black to black and white to white, and I'll just be sticking with the basic submodules. The tetra modules are paired up left and right, and if you join 6 of them together, they form the face of a tetrahedron. And if you take 4 faces of this module, they can be joined together to create the tetrahedron. In a similar fashion, the octa modules can be paired up, left and right versions, and 6 of them can be assembled together to form the face of an octahedron. And with 8 of these faces, they can be joined together just by joining the adjacent same colors, and these will come together to form the octahedron as you see here. This has 48 octa modules, and this is comprised of 24 tetra modules. So at the core of the system is the black tetrahedron and the white octahedron. However, by mixing these two parts together, various other shapes can be created. For example, if we took the 4 faces of an octahedron, the white pieces can be joined to the black pieces, and this now can be brought together to create the cube, which is represented by the blue faces on all of these parts. This can then again be sort of partitioned into yet different submodules and rearranged in a different fashion. Now with the blue touching each other, and we take a few more, 8 of these submodules will produce the rhombic dodecahedron, with the orange faces being shown. So this is one of the submodules you saw earlier, and this submodule can be sort of rearranged, and in effect shows different colors. And now we can take a cluster of these and have them rearranged and joined together, and 12 of them come together to form yet another version of a rhombic dodecahedron. This can be separated in half, partition back into the original submodules, which will also reassemble back into a cube. Now here's another example of taking another submodule and rearranging it into different shapes. This now shows the two-tone green faces. Now these can be joined together to create a new submodule. And these now, 6 of these can be joined together. And they'll create yet another version of a rhombic dodecahedron that have the two-tone green colors facing outwards. And now this can be deassembled into different shapes. As you see here, the cube can be extracted from the center of this rhombic dodecahedron, and then these new shapes can be assembled into another version, the same version of a cube. And the cubes can actually be joined together to make larger cubic shapes. Now this next shape I'm going to demonstrate requires assembling tetrahedrons with half of a octahedron. In this case, the white and black sides are joined together. Do that again and again. And fairly slowly, a much larger shape will start being formed. As you see here, now we've got a cube octahedron